Hi there, Mr. Friedman. Today I'm going to be solving a problem where we have somebody throwing a ball or object off of a building of an initial height and at an initial speed, and from there we have to find the range. So the easiest way to do that is you take the initial speed and you have to find the constant horizontal speed and multiply that by the time. So say our building is 30 meters tall, like this. So then our person standing here and take their ball and they throw it at an angle of 30 degrees. That's 30 degrees. Say they throw it at an initial speed of 20 meters per second. So then we know from the rules of special triangles, a 30, 60, 90 triangle, if this is 20 meters, this is 2x, this is x, this is gonna be 10 meters per second. And then we know that this is gonna be x root 3, so 10 root 3 meters per second. So now from here, we already have the horizontal speed. So if we're finding to find our range, the horizontal equation is going to be range equals velocity times time. So range, we need to find, so right now we have the velocity, so 10 root 3 meters per second times the time, which we can find, the time we can find pretty easily using the full distance formula. So the simple one is just y equals 1/2 at squared, but we need to complicate this a little bit more and add in plus the initial speed of the y vector times the time plus the initial height, or the initial height of the building. So we can plug all these values in. So we have 0, which is the desired y value at the very end, is equal to 1/2 times -10 for gravity, because gravity is the acceleration in this case, times t squared plus the initial velocity of the y value, which we have here is 10 meters per second. So we have 10 meters per second times t plus our initial height of the building is 30 meters, so plus 30. So then we have 0 equals -5 t squared plus 10 meters per second t plus 30. So once you apply the quadratic formula here, you get that time is equal to either -1.6 seconds or 3.6 seconds. Now -1.6 seconds does not make sense because time can't really be negative in this case, because -1.6 seconds would mean that the ball is still in his hand. I guess he's holding it a couple seconds before him. So if our time is, say, 3.6 seconds, then we can use that to come over here and fill in the rest of our equations. So we have the range equals 10 root 3 times 3.6. Now, if we use the calculator, we can go 10 root 3 times 3.6. And for that, we get about 62.35 meters. And that is our final answer.